So a reaction can appear feasible or not feasible based on the E cell value. It's feasible if the E cell value is positive. It's not feasible if it's negative. But in reality, that may not be what you see. And there are two main factors to consider here. One is the rate. A reaction could be feasible, but it doesn't say anything about the rate of that reaction. So the activation energy might be very high. So the reaction is feasible, but it's incredibly slow due to this high activation energy. And the E cell values and electropotentials will give you no warning of that. The other thing to bear in mind are non-standard conditions. Reactions are rarely done at 298 Kelvin, 100 kPa, and certainly the concentration is the big one. Everything's got to be 1 mole per dm cubed. And that's also assuming everything's in solution. So as soon as you go into non-standard conditions, the electrode potentials that you see no longer apply. They change. And we'll have a look at an example of that in a second. So what we'll have a look at is how the feasibility reaction can change with concentration. So here are two half equations with their electrode potentials, and what we're going to look at is could silver be oxidized? So silver, can it be oxidized by Fe3+? Okay, and if we look, you can see that no, it can't, because the electrode potential for the silver is more positive. So this reaction would actually go forward, not backwards. For Fe3+ and Ag to react, we want this one to go this way and this one to go this way. And that won't occur that won't occur under standard conditions, as you can see. Yep, this is more positive than this one. This one would actually go forward, this one would go backwards, not the other way. But if you go into non-standard conditions, if you increase the concentration of Fe3+, so you add more Fe3+, it's no longer 1 mole per dm cubed, you're going to affect the position of equilibrium. This is in equilibrium here. So the position of equilibrium will move to the right to counteract the increase of Fe3+. The more the position of equilibrium moves to the right, it affects this value here. It will increase. And these two are quite close together anyway. So if you're increasing, so you don't have to increase this very much. As it's increasing the electrode potential, eventually it will be more positive than 0.8, and then the reaction would be feasible. This reaction would be able to go backwards, and this one would be able to go forwards. But that only occurs in non-standard conditions. So things to look out for is when I talk about concentrated or dilute solutions of ions. Okay, they're implying non-standard conditions.